A very good afternoon, everyone. So, my name is Navid, and today I will be presenting on database management systems and DBMS. So, this presentation will help us understand how data is organized, stored, and managed efficiently using DBMS. So, by the end, you will see why databases are crucial in almost every industry. So, let's begin. On introduction, so data is everywhere from online banking transactions to e-commerce purchases and social media interactions and business records. Everything is stored in databases. But how do we efficiently store and retrieve? And upon that, how can we manage such massive amounts of data? So let's get on an overview with it. A database management system plays a key role in handling the information. In today's sessions, we'll explore its definition, importance, types, architectures, SQL fundamentals, and also security measures. Understanding DBMS is essential for anyone working with data. So, without data, there is nothing in this world. And when you have to work with data, you should understand how DBMS works. So whether in software development or business or research, it doesn't matter. You have to understand DBMS if you are working with data. So getting on the overview. So what's the definition of DBMS? A database management system is a software that allows users to create, retrieve, update, and manage databases efficiently. It acts as a bridge between users and the database. It also ensures smoother interaction with data actually. So why DBMS is important? Why is it important actually? Without a proper system, managing a data would be chaotic. Just imagine if there is no DBMS, how would you allocate your data, and how if you are allocating and you are storing something, how can you find you can't possibly go through every individual data and find your searching data. So where it helps, it can reduce data redundancy, where it avoids duplicate data storage, and it also ensures data integrity, where it is maintaining an accuracy and consistency. Upon that, it is also providing security actually, where it can prevent unauthorized access and supporting multiple users like enabling concurrent access without conflicts and etc. So after the importance, its real world application is very important. So where is DBMS used? Literally, DBMS is used everywhere. In banking systems, they use it for transactions processing and secure data storage. Okay. And in e-commerce platforms, they're using to manage product catalogs and customer details and orders, whatever they are getting. And the most important thing where they are using right now and what we are using in our daily life, it's literally social media networks where they use it to store profile data, interactions, and multimedia and etc. And there are many types in the database. Like different application requires different types of databases. So let's look at the main types. So the first type is a relational database. These are the most common databases where it can store data in structured tables in rows with columns. A table can always contain a row and column. So they use SQL language, where it's known as structured query language. So what purpose they are going to use it? They're using it to manipulate the data. For example, it can include MySQL and PostgreSQL and Oracle database actually. So as we speak about SQL database management system, there are also NoSQL databases. So what it's actually designed for, or it's designed for handling unstructured or semi-structured data. So the NoSQL databases can provide flexibility and it can also provide scalability. So they are used in big data and real-time applications. For example, it can include MongoDB and Cassandra and Redis. So these are the NoSQL databases. If you are going for a minimalist database, you can always go for a NoSQL database. There are also other database models. Apart from the relational and NoSQL databases, there are also three kinds of database, which are hierarchical database and network database and object-oriented database. So hierarchical database is nothing but data is stored in a tree-like structure, where as you know, in data structures we have read about tree structures. So that's where the hierarchical databases use it. So in network databases, if you're having a complex relationships between your data elements, you can always go for network databases. It is always reliable for complex relationships. And as the name says, the object-oriented databases stores data in object format, where it is actually used in advanced applications. And let's go into the architecture of DBMS. The way a database is structured determines its efficiency and performance. So there are three main architectures. So first tier architecture is all components reside on a single machine. So this setup is mainly used for development and testing environments, where a developer has a direct access to the database without any intermediate layer. So if I'm a database developer, I should have my uh, direct access to the database. That's where first tier architecture comes in. And the two-tier architecture is like the client server model actually, where the client communicates directly with the database server. It improves performance, but as the performance improves, it only has a limited scalability. So to get over the first tier and second tier architecture, the third tier architecture goes with the most scalable approach it consists of. So there are three layers in it: user interface layer, and that's where the front end and the users interact with. And the second layer can be the application layer, where the business logics and process records are handled over there. And the final layer is a database layer, so that's where the data is stored and manages efficiently. So this architecture is used in large scale enterprise applications. So for what purposes means it can be used for better performance, security and scalability comparing to the previous two architectures. So getting into the SQL fundamentals and SQL commands and overview can go on. So SQL or a structured query language is a standard language used for interacting with the relational databases. So SQL is divided into different categories based on its functions, and data definition language can be like and defines the structure of the database actually, where there are three commands mainly, which is create, alter and drop. So if you have to create a table, you are going to use a create table and table name and following through. And if you have to modify the table structure, you're going to use a alter command. So once you have created and altered whatever you have done, you're done with your table. So if you have to delete your table right now, that's where you're going to use your drop command, which totally deletes your table. So once we have defined the structure of the database, we're going to manipulate it. What's the use of the database if you can't manipulate your data? So that's where data manipulation language comes in. So where it can manages the data within the tables actually. So I have created my table and I have modified my table structure. What I'm gonna do, I'm gonna insert new records actually. So that's where the insert commands comes in. Using insert and the values inside it, I'm gonna insert my values in my table. So I have once I have inserted my elements, what I'm gonna do means, for suppose instead of my name I have got my friend's name, I'm gonna use my update command to modify my existing record. So if I have given an one more unwanted extra record, what I'm gonna do is I'm gonna use my delete command to remove it from my record. So that's where the data manipulation language comes in. So mastering SQL is a crucial for database management, and it's very efficient for data retrieval actually. So apart from what are the structures and what are the architectures, what clients actually look for is the single thing and very crucial for database management system. It's actually security. So with data breaches on the rise, database security is a top priority. There are many threats to database security. Databases are vulnerable to various threats, including unauthorized access. That's where hackers or insiders access sensitive data. So imagine someone access your data and they breached it and given it to their opponent companies, and that's where millions of dollars will be lost. There are also SQL injection attacks, like exploiting vulnerabilities to manipulate your queries. They can literally manipulate your queries if you have done the SQL injection attack. So apart from that, the data breaches leaks the expose of a confidential data. Imagine you're storing your country's very crucial nuclear reactors codes, and if someone have breached into it, that's the end of us. So that's where the threats of database security has done. So what can I take to prevent my unauthorized access and database use authorization? So there are also techniques such as usernames and password. It's the very most basic method I can give for authorization. So there are also multi-factor authorization MFA. So it can add an extra security layer for it. And apart from that, if you are using biometric verifications, it is the most enhanced version of security that you can give a fingerprints or facial recognition and voice recognition, whatever you can. So that's where the authentication method comes in. So once it is done, the access control takes the place where your security is the most crucial thing. So to further enhance security, database uses access control mechanisms such as role-based access control and mandatory access control and discretionary access control. Where RBAC, the which is a role-based access control, it can grant permission based on our user roles. So if your user role has a particular access control, that's the RBAC in action. And also there can be mandatory access controls. It can enforce strict security policies. You can't actually breach your security policies in the database management system. So, and the last access control, which is also directionary access control, it allows your data owners to set permissions. If I'm here and I have a data, I can set only my friend can visit my records. So that's where directionary access control comes in. A well secured database ensures data privacy, integrity, and compliance with industry regulations. So that's what we call a well secured database. In conclusion, and to summarize, database management systems, it is essential for organizing, storing, and securing data efficiently. So we explored its importance, types, architecture, SQL fundamentals, and security measures. And understanding DBMS is a valuable skill in today's data-driven world. Whether you are a software developer, a business analyst, or you can also be a database administrator. So mastering DBMS will open up a new career opportunities. So that's where we are going to go through the future. In future, data is everything. So if you have to adapt, you have to learn database management system. It doesn't depend on your career. It can be you can be a software developer or a business analyst, anything. But you have to master DBMS to control or manipulate the data. So that brings us to the end of the presentation. Thank you for your time, and I'd be happy to take any questions now.